Hello, everyone online and those here in the room. I'm Susie Roy, Collaboration Specialist and Research Engagement Specialist here at SNOMED International, and I'm pleased to welcome you to this hybrid session of the SNOMED CT Expo. So we've essentially grouped a number of LLM-focused talks for a special lightning session. Thank you, IQVIA, for your sponsorship on that, and this is all within the Advances in Research and Innovation stream. Thank you, Delidus, for your sponsorship with our stream. So today we'll have 4 presentations. If you could please hold your questions until the very end, once all 4 presentations have concluded, and at that time we're going to have our 4 presenters come back up here. They're going to kind of gather around here, around the lectern, and then we'll have hopefully around 20 to 25 minutes, depending on time left, to have some open discussion with our presenters today and some Q&A. So without further ado, I'll ask that Dr. Youngsung Park please kick things off with our special LLM Lightning.
Good afternoon. I'm Youngsung Park from Kakao Healthcare. My presentation is titled Development and Evaluation of SNOMED City Automated Mapping Tool, Advancing Terminology Standardization and Semantic Interoperability. This slide outlines the structure of my talk. I will begin with the introduction, then cover the methods, present the result, and conclude with challenges and future work. Yeah, this is the introduction. We all know the promise of real-world evidence. We sit on massive amounts of health data, but reuse is still blocked by fragmented local terms, lots of free text, and privacy hurdles. Our answer is HLS, the Healthcare Data Research Suite. It's a platform that lets many hospitals work together using standard data models, advanced AI tools, and privacy by design. The core is semantic interoperability, making data carry the same meaning everywhere. We do that by mapping clinical terms to standard code systems such as SNOMED City, LOINC, and RxNorm. So the same concept is coded the same way across sites. At first, we started with manual terminology mapping, but it quickly became a bottleneck. As you know, it is labor-intensive, slow, and constrained by limited expert bandwidth. On top of that, human error and mapper-to-mapper drift caused inconsistency across teams and institutions. To break this bottleneck, we introduced AI. The AI handles repetitive, high-volume tasks and surfaces high-confidence mappings, while experts like clinical terminologists could focus on judgment-heavy edge cases. This delivers fast, more accurate, and more consistent results, and unifies pre- and post-coordination in a single seamless workflow. In HLS, SNOMED City is our core terminology for clinical data. It gives us one shared vocabulary across disorders, procedures, labs, and more. So data means the same thing across systems. It also supports post-coordination to express precise clinical ideas. And with its rich hierarchy and attributes, the data is highly computable. We can run precise queries, find the right patient, and build a clean cohort. Okay, let me walk through the overall workflow. As you can see in the figure, it splits into 2 parts. First, auto mapping. We generate and rank SNOMED City candidates and pick the best match. Second, if there's no exact match, we also a post-coordinated concept. And the final mapping tables goes into the mapping database, and the mapping database is linked to the reference term database, which includes the previous mapping results of local terms. Next, I will go step by step through the workflow. As shown in the figure, the auto mapping process consists of 3 steps: pre-processing local terms, syntactic mappings, and vector similarity mapping. Auto mapping step 1 is local term preprocessing, and it consists of 3 pipelines. First, we remove unnecessary symbols by extracting non-alphanumeric characters and having clinicians decide what to keep. And second, we expand abbreviation to their full terms with expert review to reserve context-specific meanings, since the same abbreviation can mean different things in different contexts. Third, we translate Korean terms into English using Gemini or GPT, depending on the deployment. Step 2 is syntactic mapping. This step applies 3 rules to control accuracy and speed. First, we prioritize a browser-like search confined to the SNOMED city description table and enhance it with a custom reference term list built from validated mappings. Second, we improved performance by narrowing the search scope using domain-specific semantic tags. For example, for the diagnostic domain, we limit candidates to the disorder, finding, situation, or event semantic tags. When needed, we restrict searches to the descendants of our anchor concept. For example, for culture medium dataset, we limit the search specifically to the descendants of the culture medium concept. Third, we ensure consistency by reusing mapping for duplicated terms across institutions when domain aligns. In the vector similarity mapping phase, we automatically map local terms to standard code using vector similarity search. We built reference terms from SNOMED city descriptions and from local terms already mapped to standard codes. These reference terms are the basis of similarity matching and are embedded as a part of the pipeline. And depending on the deployment, we used embedding models on Google Cloud or OpenAI. And the resulting reference embeddings are stored in the WISE vector database. This figure shows how we also use SNOMED city concept using post-coordination in 4 steps. First, we chose a focus concept and follow the proximal primitive modeling principle, so classifiers can infer the closest supertypes. We used Snowstorm's authoring form API to pull the focus concept relationships and fully specified names, and to get suggested proximal primitive concept as well. Second, we modeled the concept under MICM rules with guided naming. The UI only lets users can pick attributes that are valid for the focus concept domain using the MICM domain attributes API. And it restricts target values with ECR-based queries. Third, we ran classification and validation in parallel with the SNOMED release validation framework and SNOMED OR toolkit to ensure quality and consistent subsumptions. Finally, we integrate the new concept into our mapping table and maintain our Kakao Healthcare extension that includes all international concepts plus our locally authored concept under dedicated namespace. We evaluated performance on diagnosis and surgical procedure codes from 4 university hospitals. Accuracy was measured against a gold standard manual set using top 1 and top 5 approach. For each site, we ran 2 stages. A baseline using only our SNOMED City Kakao Healthcare descriptions, and an augmented run that added reference terms from the other hospitals to quantify cross-site gains. Efficiency was benchmarked with 6 months of time logs across preprocessing, new concept authoring, and validation, comparing tool-based versus manual for percent time and staffing reductions. The tool chart on the screen shows the tool's accuracy evaluation result. Both charts show top 5 accuracy. Blue is the baseline, and red is after adding reference terms. You can see consistent lift across domains. In the diagnosis domain, average top 5 accuracy rises from 87.4 to 94.9%. In the surgical procedure domain, it increases from 82.5 to 91.3%. So while both improved, surgical procedure domain performance remains below than diagnosis domain. Now, turning to the qualitative evaluation, efficiency and workflow. The figure shows time before in pink and after tool adoption in green. Since deploying the mapping tool, our manual mapping rate dropped from 100 to 70%, so 30% less manual work. More importantly, we compressed cycle time at every stage. Average mapping type per item fell from 10 to 2.4 minutes, new concept creation from 12 to 3, and review error resolution from 8 to 2 minutes. It's a 75% reduction. And the biggest gain is final validation of mapping, cut from 30 to 3 minutes, 19% reduction. And finally, here is the user interface of our mapping tool. On the auto mapping screen, you can upload a CSV file of source term and digital source terms. And candidate mappings appears on the right and ranked by confidence. Users can accept their suggestions by tool or perform a manual mapping instead. The authoring page is just as streamlined. First, select the focus concept, and the system proposes the proximal primitive candidate, and you can edit or add attribute value pairs for modeling the concept. And enter the FSN, then run classification and validation. Finally, the new concept is created and added to the mapping table. We analyzed why auto mapping sometimes fails and identified 3 major challenges. First, invisible local terms. For example, in the surgical domain, we found local terms describing only anatomical body size or only surgical materials without specifying the surgery itself. These cases are inherently unmappable by automation and had to be manually labeled as not mapped. Secondly, missing granularity. Many Korean hospital local terms include fee billing-related terms that are broader or more specific than existing SNOMED city pre-coordinated concept. Such cases require creation of new concepts through post-coordination. Since no pre-existing concepts matched, the auto-mapping process could not complete successfully. Third, abbreviation issues. We used only rule-based approach for abbreviation handling, which turned out to be insufficient. Even the same abbreviation can represent different meanings based on their context and domain. So this ambiguity often led to auto-mapping errors and incomplete matches. Through these observations, we learned that human judgment remains essential, and AI is powerful assistant for humans, but it cannot yet fully replace expert decision-making in terms of medical terminology mapping. To overcome these challenges, we are planning several key upgrades to our mapping tool. First, we need context-aware abbreviation resolution. In our current system, abbreviation handling was purely rule-based, as I mentioned. So now we are combining external medical dictionaries with RAG, namely Retrieval Augmented Generation, to let the LLM understand the surrounding context of concept and choose the right expansion automatically. Second, we will use graph RAG to enhance semantic retrieval. By leveraging SNOMED city's rich hierarchy and relationships, the LLM can search for related concepts based on the concept meaning, not just text similarity. Third, we are introducing MICM-guided new concept authoring by LLM. By using attribute value recommendations derived from MICM rules, the tool can assist users in authoring new concepts. And LLM can also automatically generate proper names following the SNOMED city naming conventions. This should make post-coordination and new concept authoring much faster and more consistent. First, we are improving our embedding models and pre-processing pipelines. We are currently testing new embedding models and experimenting some LLM-based pre-processing to further improving mapping accuracy. And finally, we will focus on quality assurance for multi-institutional research. In large-scale standardization, it's not just about mapping fast. Maintaining consistency and data quality across institutions is even more important. So we are planning to use some clustering methods or LLM-based validation to automatically check for inconsistency of mappings and ensure high-quality mappings across sites. So our goal is clear: to build an intelligent LLM-powered mapping platform that's faster, more accurate, and scalable, supporting for multi-institutional research. Thank you so much for your time and attention today. It's been a pleasure sharing our work with you.
Thank you. Turn on? Okay. Thank you very much, Youngsung. So Andrea's going to come up here, and she's going to be speaking about towards LLM-based annotations of German clinical forms with SNOMED CT. For those of you who are just joining online or in the room, just to remind everyone that this is lightning session LLM focused. And so that's why we have a little bit of a different stream and a little bit of a different format here. We have 3 more presenters who are going to do their talks, and then at the end we'll do Q&A. Thank you. Go ahead, Andrea.
Thank you. My name is Andrea Riedel, and I'm an IT employee at the University Hospital Erlangen in Germany, and I'm also a doctoral student. And probably anyone who is also working in a hospital thought, wow, now we have clinical forms, and it's more easier to capture patient data or even better in digital form, but it is not as easy as it seems to be. So we are happy today to present you our first research on annotating native clinical forms with LLMs and SNOMED CT. This project was in collaboration with the local machine learning and data analytics lab. So our university hospital has currently around 18 different departments and 70 institutes, and all of their information is stored since 2002 in one hospital information system. And we have around 1,800 forms, so each department can create their own forms for their specific use cases, and that leads to a lot of redundancies and overlaps. So the same information can be stored under different names or with abbreviations, and there's currently no standardized terminology that would facilitate efficient data reuse. The Medical Informatics Initiative in Germany has the mission for interoperability within and between all German university hospitals. So there are currently data integration centers implemented as local hubs, and they should make a bridge between healthcare system and medical research. And to improve that, we try to use terminologies such as SNOMED CT. On these 2 screenshots, you can see different screenshots from tumor boards, and they are showing different treatment options. And in the middle, you can see the treatment intent. And on the left side, it is fully written out, while on the right side, for example, it's just a short abbreviation. Due to the huge complexity and variety of our forms, we first focus on a more limited use case of 15 different forms from 13 internal departments. These tumor board forms are either including the patient's medical history or the decision made during the tumor board conferences. Tumor board conferences are multidisciplinary discussions of different physicians for the best the treatment for the patient based on previous clinical treatment or medication. And everything should be, of course, on the best cost-effective manner and the most modern medicine. Specifically in Germany, everything that is certified by the German Cancer Society, so each hospital that is certified by the German Cancer Society is mandatory to document this. The Medical Informatics Initiative hands out different implementation guidelines to the data integration centers, and these are called the core data set. They are separated in mandatory basic modules and extension modules. And each of these modules are based on semantic annotations, like with SNOMED CT, and the data structure is based on LHS7 FHIR. And in each of these core data sets, there are different preferred SNOMED CT codes included. So currently we are focusing on tumor board forms, but there is no specific module for tumor board forms. So we try to take a look on all of these modules and all included SNOMED CT codes, and we would expect that as we're focusing on oncology patients, of course, most of the codes should be from the oncology module. Here you can see a more detailed screenshot of this named module oncology, and you see there are a lot of different elements, and I want to go more in detail to the therapy type. And as you can see, for each of the therapy type, there's a specific SNOMED CT code and a fully specified name, such as chemotherapy. So when it goes to the annotation task, probably all of you know that manual annotation is very depending on the domain expert. It's very time consuming and resource intensive, and it's difficult to scale. So you never know how complex the task will be, and therefore we try to automate everything, but there are different challenges, and each of these challenges interact with each other. So first of all, everybody's doing research, but probably nobody or less people are publishing their data. So explicitly German SNOMED CT-based ground truth are not as available as we wish. Also in non-English speaking countries, there are less native and domain-specific LLMs available. And as we're working in a hospital, we prefer a local secure infrastructure. And as we are working with German data, also the German National SNOMED CT edition is currently limited to specific use cases. So for our research, we try to work with the international edition. And also, we need to kind of find a way to select the core data set specific SNOMED codes. And if we look on the SNOMED CT edition and LLMs, probably all of you also know that SNOMED CT is affiliation linked, so we cannot work with public LLMs quite well as they have no access to the edition. So finally, we decided for a rack-based pipeline for pre-coordinated SNOMED CT annotation, and currently we left us post-coordination as this is more complex. And first of all, we extract the different items, their contexts, and also, for example, the different answer option. We translated that with LLMs. And then we started with a vector embedding and accelerating phase search. First of all, we extracted from the online available simplifier module the SNOMED CT codes from the core data sets. These are around 1,200 codes. And then we compared different vector embeddings. First of all, the all-EmpNet, that is more like a general one and the most famous one. Then we also tested MedEmbed, that has a more medical focus. It is pre-trained on PubMed Central clinical notes. And last but not least, we also tried Biosim by Bird SNOMED, and as the name said, is more SNOMED focused. And in parallel, we also conducted a string-based similarity search with the Snowstorm server, and here we focused on the full international SNOMED CT edition. So for the first search, as we want to emphasize the MII focus, we focused on the 50 best matches, and for the second search, we just selected the 20 best matches. And then we compared two LLMs for ranking, the Mistral and the Llama, and each of them got a prompt to prioritize explicitly the MII focus. And they should hand us out the best top 1, 3, or 5 matches. So medical student and I manually try to annotate all of the 1,900 different items, and we were able to annotate around 48% with around 70% exact matches, and we had the inter-rater agreement for around 0.75. We saw that around 4.8% of the SNOMED CT concept were from the core data set, with the biggest proportion from the module oncology. And we were quite happy that our LLMs show the similar proportions as our gold standard, so there was no over proportion, even thought we say, please prioritize these codes. And our best combination was the llama model with the biosim bird vector embedding. For the top one, we reached around 46.2% correct annotated concepts, up to 47.8% for the top 5. And maybe some of you have wondered why it was we were only mapped to around 48% of the forms. That is due to that in the local forms there are a lot of proper names, like doctor names, that do not need to be mapped, or they're like administrative items, like form filling instructions that are not of interest, or structural elements as in the screenshot, these small X's. We also first focus only on pre-coordination, so of course if we would do post-coordination maybe there would be more options. And for the SNOMED CT concept selection, so every country has their own healthcare system. So for example, we would need a code for ophthalmologic department, but currently there's no code. For example, in the UK healthcare system, they differentiate between surgical and non-surgical departments. Moreover, there were some non-existing codes, like for tumor board itself, or there were some wrongly matched due to the semantic tag. So this was, for example, due to our focus of the MII core data set. There are some outdated codes already, or referring to the ophthalmologic example, there were codes preferred with the qualifier value instead of the environment, what we would prefer as manual annotators. So manual annotation still outperforms automated approaches, but we think that our approaches are good pre-annotation suggestions. We have a realistic proportion of the core data set. There are almost no hallucinations. Still, translation is a challenge, and we are further investigating regarding the prioritization of specific semantic tests, post-coordination, synonyms, or diverse data sets. And we're happy to exchange with all the responsibles from the core data set, especially the module tumor board is currently in the balloting phase. So I thank you all for your attention, and also my co-authors today, Noemi Deppenwiese also joined me in the audience, and we are looking forward to the questions afterwards. Thank you.
Thank you. Thank you very much, Andrea. And as Giulia comes up, just for those who are just joining us, just so everyone is aware that these are lightning rounds in this current stream, and so that is why we have a faster paced presentation style here. And at the end of the session, we'll have all 4 of our presenters come up to take on some questions. So without further ado, I'm going to kick it over to Giulia Baldini.
Okay, thank you. Hi, everyone. I'm Giulia, as previously mentioned, and today I would like to present a tool that we developed at LCJI with the help of SAS in Antwerp, a local hospital. And so what I'm going to talk about is first the clinical workflow. So I'm going to explain what is the current workflow, or what should be the current workflow, and what we are improving. Then I'm going to explain how the integration works with the EHR and how we trained our model. Then I'm going to explain how the SNOMED CT code selection works. I'm going to show some results, and then we're going to talk about next steps and future work. So it's a bit small, but what you can see here is theoretically an EHR. In this case, this is Higgs from Chipsoft. And what you have on the right side is a conclusion that a doctor has just written. So this is in this red box. So the idea, and on the left side, what you have is a problem list. So this is a list of SNOMED coded concepts that are problems that this patient has. It can be procedures, findings, or conditions. And this is used as a summary of the patient, such that other doctors can have an overview. So the idea would be that theoretically, when a doctor writes a conclusion, they can then basically add the new problems that they found during this encounter to this list, such that this list is kept updated, which is good for data quality, but also for interoperability and many other things. The problem is that obviously they have to do this manually, so it's not so great. And this is what we built. So we built basically a tool that automatically analyzes the conclusion and then gives a list of SNOMED coded problems that do not already exist in the problem list. The doctor can then validate these problems and add also some attributes. And then these problems are sent and stored in the EHR. So how does this technical integration work, or how it's supposed to work? So our tool is actually an EHR integrated tool. It's EHR agnostic also, but currently our integration is with Higgs from Chipsoft. And the way this works is we use FHIR APIs for integration. So this means that we receive the existing problem list as a FHIR, as a FHIR bundle containing conditions. And then when the doctor has validated the problems, what we do is we send back these problems also in FHIR standard as a bundle of conditions, such that they can be stored in the EHR. How did we build this model? So that's what I said before. So what we did is actually we fine-tuned the model. What we fine-tuned is a 24 billion parameter LLM, a Mistral model from a Mistral AI. And we co-developed this with ZAS here in Antwerp. And the way we did this is we actually annotated around 1,200 letters. You can see the numbers there. They are around 150 letters per specialty. You see here there are 7 specialty plus others, so there are other letters that did not fit in these specialties. And we had 6 doctors, actually clinicians, expert in their own specialties, that annotated this letter for us. And then what we did is, since we are using a relatively small model, a 24 billion parameter, we decided to split the task of extracting problems, mapping SNOMED codes, and comparing with the problem list into smaller tasks. So basically what we did with this data is then we created multiple tasks out of it, which explains why from each group of letters we actually got many samples. So here you see that we have around 100,000 samples that we trained our model with. How the tool works is basically we have a sort of coordinator agent in the middle that has multiple tasks that have to be performed such that we can get to our goal. So the first most important thing is we need to identify problems in the conclusion that was just written. So this conclusion is collected, we identify a problem in natural language, and then we have several steps that have to be performed. One step is actually checking that this problem exists, so we avoid hallucinations and any things that LLM might not do properly. Then we also find any metadata about these problems. So for example, status, so it could be that a problem is not confirmed, or it could be that the problem affects one part of the body, left or right, or both, or unspecified, and dates. So it's also important to know when a problem occurred, and this is also found in this step. Another step of this is finding out whether a problem is relevant enough for a particular specialty. So since we have 7 different specialties at the moment, it can be that some problems might be relevant, for example, for intensive care, which is a specialty that is more based on emergency and not relevant for example, nephrology. So we actually have a step where we check this. Otherwise, these problems will end up in another category such that they can retrieve if needed, but otherwise they are not presented to the clinician straight away. Another step is then comparing with the existing problem list. This happens in two different ways. So there is a semantic comparison using the LLM. What this does is basically checking that the problem we found, if it's similar, and also if the dates match. So the dates are also used for this because this is obviously also very relevant. And also we use the SNOMED city hierarchy to understand whether, for example, the problem we just found is maybe a child of a problem that is already in the problem list. If this is the case and the date is similar, then it's probably very likely that this is the same problem, so it should not be presented again to the clinician to be added. And then, I mean, it's not the last step, but the most important step maybe for this audience, which is how do we map these terms to SNOMED city? And this is what I'm going to talk about now. So many other people mentioned embeddings today, so I wanted to explain very briefly what an embedding is. So what an embedding is basically an n-dimensional vector. There is a little arrow in the middle that you cannot see, but basically from the word hypertension, you can basically get a list of numbers that has n dimensions, let's say, and this is basically a vector representation of this word. So let's say this holds the semantic meaning of this word. And what we've done is we have created an embedding for each concept that exists in the SNOMED city Belgian extension. And we did that for a set of SNOMED city, not for SNOMED city codes, not for all of them. So we did that for disorders, procedures, findings, but only the findings that exist in the SNOMED city ref set, SNOMED city Belgian problem list reference set. Yes, and then all of these embeddings were stored in an Elasticsearch index. This is a tool that can be used for search, and they are ready to be queried. The way this works then is, so how do embeddings work in general? So we have this n-dimensional representation, and these representations can actually be plotted. The human minds cannot really comprehend n dimensions. It's a bit complicated. Usually we go well with 2 to 3 for understanding. So here I've plotted it in 2 dimensions because otherwise it's a bit complicated. But these are actually the real embeddings scaled to 2 dimensions. So this is actually how it works. So here you see I just plotted some of them. You can see diabetes mellitus step 1 and diabetes mellitus step 2. They're close together. Then you have various kidney disease with different stages. Then you have hypertension, and then you have chronic kidney disease stage 3 due to benign hypertension. So you see that this last one is actually a bit separated from the others. So you see that here, this plotting in this space actually holds some sort of meaning, and this is what we leverage when we use embeddings, basically. And yes, so the closeness in this space basically tells us how related, how similar two concepts are. And so the way our SNOMED city selection works is that basically we have found these terms in natural language now. So for example, let's assume I just found hypertension, and now I want to see what are the closest terms. So here I've put hypertension in red, and you see here that the 3 closest concepts are these ones. However, this might be misleading sometimes. It might be that concepts that are close are not exactly what we want, and also there are multiple. So this is why people use retrieval augmented generation, or RAG. And what you usually do is do something similar to this. So basically you just give an LLM a selection of terms that you found, and then you ask for this particular letter that I've written here, what is the one that fits best? So looking at this context and looking at these codes, which one do you think fits the concept best? And then our LLM will return one of those. So what we actually do, so I said before that we did annotations with clinicians. So actually what we did with our training, with our fine-tuning, was actually that we want to teach the LLM how the clinicians have selected SNOMED CT codes, and we want to be able to do it in the same way that the clinician does it. And we use all SNOMED CT designations or synonyms, let's say, so other words to describe the same concept, such that we can provide the full context to the LLM. And we also provide the LLM with a hierarchy between the concepts, such that is, for example, easier to say, so this concept is more down the hierarchy, so this means that it's more specific, so the model can choose the most specific concept that still applies to the context. So these are some results of the proof of concept that we did together with the hospital in ZAS, with 6 doctors from 6 specialties for 300 previously unseen conclusions. And what you see here is so you always see the percentage, and below you see basically the numbers that made out this percentage. And the doctors were asked to either say, so the model was predicting then these concepts, then it was, they were saying whether the concept was completely wrong, so whether it was assigned a completely unacceptable SNOMED CT code, whether it was partially correct, but there was probably a better SNOMED CT code for this concept, or good, whether it was actually a good concept that was accepted. So what you see here is we have a score of around 92%, and you see that this varies between the specialties, and you also see that the specialties also vary in the number of concepts that exist. So you see, for example, in intensive care, you have many concepts, so around 850. There is a lot, they have very long letters and contain a lot of information, while cardiologists and pulmonologists have less, so you see 126, 189, also rheumatology, 158, so they have shorter letters with less information, or I mean, only these concepts, let's say. Yes, and you see also they have different scores, so the judging was also different, and yeah, so this is what we got out of it. Future work, so obviously we're still working on it. This is very good. Yes, so what we would like to do also in the future is we also want to experiment with embedding models trained on SNOMED CT. So what we use now is actually general purpose embedding models, in particular one from OpenAI. So these are good, but sometimes with clinical, like with medical terms, they are sometimes not specific enough. So it's maybe good to have a try also with SNOMED CT specific embeddings. Then what we also would like to do is also collect more data from different hospitals, from our specialties, and also from the Netherlands, for example. And then now we're actually going to be live with this product in November, December. So we are also going to collect feedback and understand what the limitations are and make improvements accordingly. That's it. Thank you very much.
Thank you, Giulia. Thank you very much, Giulia. And we'll bring up Hugo, or, oh, there's 2. That's what I was wondering, okay. So we have 2 presenters finalizing our lightning round of LLMs here. And so just for those who just entered the room and also online, this is our LLM lightning rounds. We have 4 groups presenting today, and at the very end of this presentation, we're going to have everyone come up and we will take all of your questions. So please proceed.
Thank you. Good afternoon. The title of our presentation is Employing Large Language Models to Clarify SNOMED CT Concepts for Patients. And my name is Rafaela Vlot. I'm working as a terminologist for the SNOMED National Release Center of the Netherlands. And last year we worked hard to realize patient-friendly explanations to SNOMED CT concepts. And would like to introduce you to our way of working and to our plans for the future. And my co-presenter, Hugo van Mens, will discuss the results from a comparison they made from our output of the explanations to the output of a large language model. So what did we do? Just a moment. We added last year a comprehensible explanation to 15,000 SNOMED CT concepts to give a first impression and explanation to patients. We introduced the patient-friendly term, if it was possible, and for every concept we added an explanation as an annotation in a patient-friendly reference set, and this in the Dutch SNOMED edition. And this annotation is a new issue that SNOMED International introduced for adding metadata to concepts. And we use it to introduce same clarifications to multiple concepts to meet the needs for patients. For example, you see here the concept onycholysis, and it means the patient-friendly term. You can see loslating van je nagel. It means nail lifting, and in English, this means that your nail is separating from the nail bed, and the nail bed is the skin under your nail. You can see it. Well, why did we start this project? We started to develop these patient-friendly explanations because patients get more and more access to their health data, and therefore they need to be able to understand what the doctors and other care providers are writing about them. The project is a cooperation between the Ministry of Health, Welfare and Sports of the Netherlands, the Dutch Patient Federation that represents more than 200 patient organizations, and MedMij, it's the Dutch Health Foundation that facilitates digital health exchange between patients and care providers in personal health environments, and also NICTIS, we as National Release Center participated. How did we start? We started developing guidelines that should be followed by developing the patient-friendly explanations. I'll give some examples of these guidelines. One of the general guideline is that the explanation should be timeless. And about the guidelines on the language level, we decided that the terms and explanations should be written at the B1 level of the CEFR, the Common European Framework Reference for Languages. And the term should consist of one word, a few words, or a short description of a maximum of 8 words. And the explanation should consist of a maximum of 4 short sentences. And now we treated the diagnosis, and for the diagnosis, we had a guideline that we don't mention symptoms or treatments or prognosis. And about the level of detail, we've chosen to add the patient-friendly terms as synonyms to the SNOMED reference set. This means that we add the patient-friendly term only to the SNOMED concept that represents the exact meaning, and we can only use the patient-friendly term once for that concept. And it would be perhaps desirable to being able to add more than one patient-friendly term to multiple SNOMED concepts to need the patient to. And we will reconsider that perhaps in a later point in time. For the explanations, the rule is that detail is less important than the medical meaning. There's no need to explain the full meaning of the concept. For a lot of concepts, the full meaning would be too complicated to explain to patients. We say understanding is more important for patients than detail. How did we proceed? The first step in the process that we as NICTIS distributed sets of about 50 terms to the Medical Translation Agency. And those batches of 50 terms were clustered concepts that we as terminologists put together to get some meaningful sets of terms. Then the Medical Translation Agency translated the medical fully specified name into the short explanation for the patients following our guidelines. And they provided a patient-friendly term, if it was possible, like the example of the nail lifting. Then every of the 15,000 terms and explanations was submitted to a doctor for the medical validation. The medical validation was very important for us. And after the medical validation, all the terms and explanations were presented at a large group of patients, and they gave us feedback on how comprehensible the explanations were. And then the latest step is that we as NICTIS publish the terms and explanations in the patient-friendly reference set. We do that with every monthly release of SNOMED. And we as terminologists have a role in the project by ensuring the medical correctness related to the SNOMED concept and the application of the guidelines and the understandability of the explanation. And we as NICTIS are also providing, also ensuring the project management. Well, now that we have concluded the first phase of our project, we are investigating the use of large language models to, well, to increase the amount of explanations that we can make to a lower cost. And the aim is to clarify more concepts at lower cost, but still with a high quality. And there are a lot of questions that needs to be answered for us. My co-presenter Hugo will continue his presentation on the comparison of our validated explanations with the outcome of a large language model. Thank you.
Oh, thank you for the introduction. This is an example of how the clarifications can be used in clinical practice. This is the HICS patient portal. And they were available already since 2023 there. So patients can view their health problems on the problem list, where they can click on the information button and get a short explanation. And if there's a synonym, we rephrase it as another name for this term is something in a patient-friendly phrasing. So yeah, we implemented a previous version of this, and now it's available. But back then there was only a coverage of 7%, and now it's up to 70%. So that's a big improvement, also with the new language level. And what we saw in earlier studies that we carried out about this was actually a different study, but we read medical records together with patients, and then we tested a tool. We did a pre-post test, but we tested the tool to provide information buttons to them. And although the coverage was very low and the quality of the explanations, the patients, they were very happy with the functionality. And that tool had been live since 2018 to 2022, and this was a finding in that earlier study. And another study we carried out was we implemented the diagnosis clarifications from the previous version, but also some generalizations in clinical practice in a Dutch hospital. And we measured the use of these information buttons for 9 weeks. And what we found was that more than half of the patients actually were using the information buttons. So patients really used them, and they also could rate the quality of the clarifications. And the patients, yeah, they were happy with the clarifications, although they were not that good, to our opinion, because we had generalizations, so you lost a lot of information. And that the generalizations were a way to increase the coverage of the for all the diagnoses. It was also previously presented in SNOMED Expo. And what the CMIO of the hospital that we were collaborating with, Franciscus Hospital, it was Roelbold. His opinion was actually it's worse if you don't have any clarification. Then yeah, so he thought if it would be right most of the time, that would be good because the patients would be Googling anyway, so he was willing to use the LLM-generated clarifications. So that was a good starting point for us to question, like, can clarification generated by an LLM, can it be as good as a clarification from the SNOMED CT patient-friendly ref set that was developed by linguists and validated? And we used Gemini Flash to generate clarifications for all diagnoses that are registered in the Netherlands. And it was not even there was already a new beta model available, 2.5. But we did a validation of 60, only a small set of the clarifications. And then after that, we had carried out a survey in the general population, which we had like 172 responses. And we measured the comprehension before and after viewing the clarification, where we did actually a crossover design. So we did one time they get first the SNOMED CT clarification and the other time the LLM clarification. And we also asked about the satisfaction. So what we found was actually that we found some minor errors in the clarifications. But we don't know if this, if the medical, if the translation agency also makes errors, so it's difficult to compare. But they were minor errors that we think it would be that much of a problem in practice. And what we also found, that there was no significant difference between the comprehension and satisfaction of the patients. So given that the costs were much lower, because we only spent €4 to generate the clarifications, and it was a factor of a couple of zeros lower. I cannot say, I do not have the exact number, but then the other process. So that's very promising. And there are also some other considerations that we have to take into account. Of course, the SNOMED CT clarifications are validated, but it is also important that they're stable in time. So it's not like today I get this clarification and tomorrow it's another clarification. And another requirement is that it's equal for every user. So you want the doctor to know the clarification that the patient gets. It makes sense to generate the clarifications with a large language model, but then to store them and validate them, so you can release them and you have stable validated clarifications. Another consideration is the coverage. So the large language models, they have a higher coverage because you can just generate a new clarification if you have a new concept. And you can also apply it to free text notes. As we see the previous presentations, if you have entity linking, then you can also provide, make an info button. So the idea is that you can use the large language models for new content and also use them to link free text to the SNOMED CT existing clarifications. Something went wrong with the sheet, I think, but so yeah, overall I think a combination of both approaches would be more interesting to uptake by the standards or the National Release Center. So what we showed is that it's feasible to generate these clarifications with LLMs, and there. There were some limitations because we had a small study population with relatively more students than the normal population, but also we tested we developed it with multiple language models, but we tested only with one. And another challenge is measuring the comprehension, because we just measured, like asking them with the teach-back method, like, what do you think this means? But it was only at that point in time, so we didn't measure the comprehension over time. That could be better, of course. So we have some more open questions, like should we validate like all of the content, or can we validate a small selection? yeah, and due to time, I'll continue here. So I think some key points I want to give, some implications. So I think national release centers can really learn from this work that NRC Netherlands did, and maybe even use the clarifications that were already made. So you could translate them to your language, because they are already validated. So that's a quick start. And it's we would advise to use them in the translation process. So next challenge is to implement it in clinical practice. Yeah. Thanks for your attention.
Thank you, Hugo and Rafaela. So we just heard 4 presentations utilizing large language models for mapping local terms to SNOMED CT, annotating clinical forms. This is where my memory gets tested. Problem list maintenance and clarification of patient-friendly terms. And so what I'd like to do now is to please ask our 4 or 5 presenters to please come up and gather around the podium. I'll let those in the room to think of your questions while you're thinking, and I'll also check online. I'd like to ask our presenters today, so obviously SNOMED CT is a key component in all of your research. And while I am scared as a SNOMED International staff member in asking you this, however, I have to as our research engagement lead, what can SNOMED International do that will help you with SNOMED CT and assisting you to further your research? Whoever.
Hi, thank you for asking. That's very nice. Yeah, so I think a very important thing that SNOMED CT is doing is also like enhancing and improving always the interoperability with other standards. So like fire terminology services, ICD mappings, I mean, this exists, for example, in the Netherlands. So I think this is very important because it makes everything much more connected. I heard yesterday that they also have a further cooperation with OpenEHR. So I think this is actually what is right? Because we have to work together. Our company, LCJI, is focused a lot on making structured data, so that's our goal. And this makes everything much easier for everybody if we can just agree on standards, follow them, and yeah, try to go in that direction, basically.
I mean, today we saw that everybody has like similar opportunities and challenges in their research, and I think it's quite important that we have like meetings like the Expo or others to see that everybody's doing like similar research, and we need to exchange with each other, and it's nice to meet the other colleagues today.
Yeah, and I would like to, I like the suggestion of the keynote speaker today that we have only the MIMIC dataset, and what would be nice if there would be available more corpora annotated, so we can share research together and improve our models and clinical practice in the end.
A lot of you nodding in the audience on that one.
I'm very impressed by how you guys utilize LLMs in SNOMED CT, and I hope that when we develop our authoring tool, in-house authoring tool, it is a little bit difficult at first to utilize our toolkit or validation framework toolkit. So if there is a little bit more kindly, user-friendly manual, it is better to implementation for other users, I think. Thank you.
That was a good one. Thank you. Thank you. I'd like to open it up to anyone in the audience. I'm going to check online too. If you have any questions, please go ahead and step up to the microphone. Mine. I actually had another one. This one I think was for Andrea. Yeah, because you had a section about mentioning something about your reasoning not what was it? essentially, what are some of the privacy concerns that you see that you sort of mentioned around the reasoning for not having public LLMs? And I just wondered a little bit more on your thoughts on that one.
Yeah, I think it's more like a copyright issue because they're quite individually designed by the different physicians in each department. So we want to make sure that they keep their trade rights.
Okay, thank you very much. Youngsung, since adopting the LLMs, what benefits and what drawbacks have you observed? And in which areas do humans still perform better in based on your research?
As you know, LLM is very fast and consistent, especially for repetitive work. And in some area, especially with straightforward synonyms or very common terms, it performs better than human in my experience. But it has weak points as well, and they include some handling abbreviations or missing context. So to reduce these drawbacks, we kept human review for those low confidence cases. And even though the LLM evolves and the high accuracy of auto mapping, I strongly believe that human judgment is still remain essential for terminology mapping. As you know, in terms of terminology mapping, there is not a single code. Instead, there can be acceptable several codes depending on the context, intent, or use of mapping. So human must choose the best answer among those candidates. So I think human decision is essential.
Thank you. And we have a question in the audience.
Yeah, it's for Giulia. We had a discussion this morning when your colleagues presented about this function of deleting already existing concepts in the problem list. And we talk, and now I understand that from your presentation that you have this step where you take away children, or you decide something with the children of the concepts. If you add a child to a concept from SNOMED's meaning of a child, then you will probably not add it to the list, as I understood you.
Yes, so basically we have this step where we basically do a comparison between what already exists and what the model found. And if it is a child of a model, so if it's a child of the concept that is already there, then we don't suggest it as to be added. This concept, so if you remember the interface, so basically there are problems that are shown,
Sure.
And then there is actually at the bottom there is another area that is not present where these similar concepts are also shown. So if the doctor feels like this problem should be added again, they can still add it.
Did anyone do that? Because I think that some of the hierarchies are very deep.
Yeah.
And so it could be that it actually could also be beneficial both for the treatment of patients and also for the patients to know that this is actually a specialization of the problem.
Yeah, so wait.
That could be a progress in the whole case.
Yeah.
If you then say, oh, well, no, we don't know about that, we only know that this is a disease of a certain high level.
So I'm not sure now if I explained it correctly, so I will repeat it again. So basically, if the child already exists and we predict the parent, then we are not going to add it. But if the child is predicted and the parent already exists, then this is shown. Yes, right? Okay, yeah. So this is then shown, and actually, so this is also an integration question, because what we would like to do is also give the clinician the possibility to exchange problems, because obviously, I mean, the clinicians do this quickly, and I mean, they don't have time, they also don't know SNOMED. So what we want to do is then actually show them, oh yeah, we found this concept, it's similar to this one, it's actually better. Do you want to exchange it so you don't get duplicates?
Get it. So I have an additional question, and that is, I was really impressed by these the satisfaction of the users of the concepts, and I think it was so high that I get a little bit anxious about the value of that information. And then I would like to ask you, is that before or after you have done your trick with the children and the
Yes, so this is a very good question because so the similarity thing, you did not see it in this course. So this is part of this course that, yes, did we show that this morning? Well, so basically the idea, so this was only for the SNOMED city data spectrum basically, and actually during the POC, because of the setting of the POC, we did not check this children trickery, let's say, but what we did is we checked the semantic similarity. So we checked basically what the model was finding as a semantic similarity between two concepts, and that was what was presenting the concepts in the different categories.
So that could explain some of the very nice statistics.
But these statistics were not showing that. So this is another thing, and we have a different thing, but yes.
Rest my case.
Yeah.
Thank you anyway.
Yeah, okay, but yeah.
Thank you.
Oh, you may stand there.
Okay.
Yeah, thank you for your presentations. I think the fun is just starting here. Fun part. I have a question for you, but perhaps for the others as well. But you showed that you used like 60 letters from each specialty to train.
Yeah, 150.
Yeah, 150. So also the question for SNOMED International and the other release centers. Can SNOMED help by making those sets, those annotated letters available for, like, you are a startup, to make it available to train and validate your solution?
Oh, so you would have more data, you mean, or?
You, as a startup, say, you want to train the AI part.
Yeah, sure, yeah.
You want to validate it.
Yeah.
So you need annotated letters.
Yes, correct.
That's a lot of work, probably.
Yes.
How can SNOMED help, or how can others help to achieve that?
Yeah, it's a good question.
Would that be helpful for you then?
Yeah, I mean, having more data would always be helpful for sure. So our plan is also to extend this to other specialties and have more letters. We actually have a plan to extend this to much more data. Open data sets are also important in this. There is the MIMIC dataset. The MIMIC dataset also has partially annotated SNOMED city linkage. The letters are very different, however, from the Belgian ones. So the MIMIC letters are much more, they speak a lot in this letter in general, right? So I mean, real data sets from Europe would be what would help best. But usually it's hard to get to data sets from hospitals. Yeah. So I mean, if SNOMED city can help with that and also with annotations and everything, we would be happily take it. I think.
That is the million-dollar question. Always.
Oh, you have nothing to do, so.
Thank you. Yeah, sure.
Anyone else? Just as a reminder, we did conduct the entity linking challenge the other year, and with that, we had a challenge to assist to annotate a portion of some MIMIC data, and so that is available. You do need to go through the licensing procedure and through some bioethics training on that, but you are able to utilize that. But yes, annotated, good quality, de-identified data is the million-dollar question that everyone is always wanting, so yes. Any other questions or any questions from the panel? If not, I want to say thank you so much for attending the LLM Speed Talks today, and thank you to those presenting, and thank you, everyone.